Next up, we're going to be talking a little bit about Travis CI, which you may recall from last week when we talked about testing in CI and CD for a bit. And so we have Anna here from Travis, who's here to speak with us about Travis CI. Turn it over to Anna.
Hi, I'm Anna. I'm a product manager and heading up involved in our education initiative. So I'm here to talk about continuous integration, which if you are involved in software already, you certainly probably have come across this, and I hope to go into enough detail that it's useful. If you haven't, we're going to start from the top. So I work at Travis CI. We are a leading continuous integration platform. It's essentially a tool for software engineers to maintain quality and collaboration. We started in 2011 in open source, moved to paid and enterprise over time. It's entirely GitHub-based, so your GitHub repositories, talk to Travis if you would like them to. Bit of a side note, microservices, Ruby, Go, Ember.js, it's cool stuff. You can find us also on github.com/Travis-CI. Also, we do have an education program, just to plug it real quick, education@travis.ci.com. If you're on the GitHub education pack, which you all should be if you have a .edu, go sign up. If you have an organization club, contact us. And there was a question earlier, there are a couple docs down there for getting started, kind of background and stuff. So all that stuff is there, but docs.travis-ci.com, it'll get you all there eventually. We also involved in other education initiatives, so through Rails Girls Summer of Code have like a paid fellowship for women and non-binary engineers getting started. So highly recommend. Some general stats about us. We are smaller than GitHub, but it's pretty cool. So right now, 1.3 million repositories have built on Travis, about that many CI jobs, and that much compute time per month. So what exactly is happening in all of that? So to back up, why do you need CI? So imagine you have a project where you have to implement some stuff. Maybe it's homework, maybe it's a product you're working on. You get this feature request. OK, we need to write this. You write it all at once. You try and fit it back in. And it always goes great. Everything merges. It's fantastic. Generally, there's some testing that needs to happen. Generally, you end up with checks. Maybe you end up doing more and more, like shorter and shorter components. Especially if you have multiple engineers working on a code base together, everyone's changes happening all at the same time is totally not a recipe for chaos. So this is where CI comes in. So continuous integration being like, let's get our changes in, continuous being happening all the time. That said, as I go through this talk, there's a bit of phrase overloading here. So CI is both the process and the concept of continuous integration, like the best practice of moving stuff into the code base over time, as well as like literally the tool. So when we say this project has CI, they probably follow CI best practices using a CI tool. So it's a bit of conflated terminology, but both refer to the kind of the same thing. The biggest thing about CI that you talked about last week is testing. So I'm going to talk from an industry perspective. John Britton showed a little bit before, but testing. So code is tested, or it should be. If it's not, please write tests. It helps. It's a good idea. Or my favorite is the YOLO merge, where you just sort of send it to master and hope. Also good. But all modern testing language, in fact, even Fortran, have testing frameworks, so use them. In JavaScript, there's Jasmine, Mocha, Jest, a bunch of others. Python has unit tests built into the standard library, but there's some interesting test runners. Nose tests is one I've used. Py.test is another. All sorts of good stuff. Many languages, Go, have tests built in. Ruby has RSpec. Like, they all exist, so you can go and find them. Also, look up Fortran. It's kind of neat. So types of tests. You can look at it from a few different angles. So, and I am going to compress all of quality engineering into about 5 slides. So apologies to any quality engineers in the audience. It's a great spot if you're into automation. So your tests can go both into automated or manual tests. I'm going to talk about automated tests, functional versus non-functional tests. Functional being like, we're going to test a function. Non-functional being like reliability, security, sort of operational things. So automated, the machine follows a script that you've written or someone on your team has written. and you assert an expected result and verify that the assertion is true. Sort of like a programmatic version of checking a hypothesis, only unlike physical and social sciences, we're going to go back and change our results until we get the hypothesis. Please don't do that, except here. So we're going to set like, oh, this string, this output is true. We expect it to be true. It's not true. I'm going to go and fix my code until it is true. So we're checking, we'll write tests beforehand or after. Beforehand's a good idea to check that things are working the way they should. As a side note, manual tests, this is literally someone manually going in and checking. Good idea to do it at times, but CI is really concentrated on automated testing. Then functional tests also are broken down into different categories. So the root word function here is like programming functions. We're going to test a function. So there are subcategories: unit tests, integration tests, component tests, others too. This is a classic diagram I just felt like I had to throw in there. You start with your unit tests, fail fast on the unit tests, and then work your way up such that a component test tests like a package, a module, a larger part. Integration test tests how things work together, and end-to-end is like an entire flow. So if you're writing a testing suite, a good idea is to start with unit tests. Does this method work the way I expect? So examples. Here's a method out of our front end. I will look at it later. It's generating the build status badge. I'll show it to you. But literally, the build is passing. Let's make this into a markdown thing. You can put into your GitHub README. That's our method. Here's our test. In a great irony of software engineering, the test is longer than the method. But it's good. What it's doing is saying, OK, here's the assertion. It generates a markdown image with a particular string that looks like this. If this is changing, then we're going to fail for whatever reason. So if this test passes, we haven't broken anything. This is great. If it hasn't, then maybe we need to go back and take a look. Good things to test for, just backing up in general, things work the way they should. Like a user can see the things they are supposed to be able to see. The string is generated the way we want the string to be generated. Or things fail the way they should be failing. A user can't see the stuff they're not supposed to be able to see. That's a good one to keep in mind, because users should not be able to see admin things and vice versa. So the idea with testing is stuff should change only when you intend it to, and you update the tests accordingly. So if you write your tests beforehand, this is a whole framework called TDD, test-driven development. Lots of folks use it. So that way you know the code you are writing matches the output you are expecting out of it. Just a general statement is it's really important to keep in mind that unlike student work, or unlike personal work even, software engineering tools are for teams. So the testing is to help engineers keep stuff from breaking things that impact other people, breaking production in unexpected ways so that when the deployment goes, this side issue has happened. It can also function as a kind of documentation. This is what I did. This is what this method is supposed to do. These are the results we expect, and this is the stuff you can rely on. So if there's no documentation in a repository, shake your head and go read the tests. So separating out, so after we've gone through tests, tests happen when we're doing a software build. So we're going, I have this code, I've written it, I've written the tests. We're going to then build this code, compile it maybe, prepare it, and turn it out to the world. So this is just the next section is just on like builds and building. Any burning questions in the meantime? OK. So builds and building. Build can both be like a verb, like build this source code into something. And this is really interesting, and I'm going to skip over this a lot, but compiled versus interpreted languages. So some languages need to be turned into a source code that is executable. Others, it's less clear-cut. So builds versus interpreted languages may jump straight into testing. Sometimes there are optimizations that happen first. This is some really cool stuff in computer languages. This is also true. So builds can get rather long. This is a classic XKCD, and I felt like I had to include it. A build is also like the end result. So the build from yesterday was broken, but today the build passed. That refers to all of the change that happened between now and then. So it's we can say the build as the end result of a build process. So we went through the 10-minute build process, and then we have the build. It functions as a kind of audit log. So here you can see me going back and forth with our technical writer, talking about, like, this is actually a documentation discussion in which apparently I had a really hard time with the passive voice. So it was thought to look great. There in specific is highlighting the GitHub status checks. So when we post to GitHub, we'll see both the positive status, like yes, this passed, the negative status, no, this did not. And it functions as kind of like a yes, this is what this commit did, this is what that commit did. GitHub's really nice and gives this in our UI, but the general concept stays anyway, that builds are highlighted, and the statuses are highlighted. You can see where it changed. I think the last one was a merge into master, in which we also fixed a hyperlink. So why CI in general as entire systems, as opposed to like, why don't I have a single machine that just sort of we test on every so often? It's to solve this problem. Hey, it works on my machine. It's going to be fine. It's always fine. And there are many different flavors of this problem. So reproducibility. Standard environments mean we can eliminate like special customizations and sort of hacks from influencing the results. So maybe you've installed additional dependencies. Maybe you have special scripts that when you know one thing happens, go do the other thing. If someone else doesn't have that, or even if your production environment doesn't have that, then what? Software is built on top of the entire ecosystem of dependencies below it. So if those things don't exist, you might have a failure in production that's really hard to debug because it works on my machine. It also helps people check other people's work. If we know the environment is standardized, we have this clean installation, we know the environment is standardized. Oh, this build failed on this separate machine. It must be the code or how we're integrated or how we're working with this like clean environment, which we can fix, as opposed to say we're working on an individual laptop. Oh, let's all crowd around and try and figure it out and hope it works in production. So reproducibility is a big deal around CI systems, and why do we have external CI systems. Also, just a shout out, collaboration is really important, because if we have these environments that we sort of can trust or at least can predict, people don't need access to the exact same thing. So I can go and work from wherever. I can go and work from headquarters in Berlin, or I can come back here or whatever. Because we're not necessarily looking at the exact same installations, we know we have some reasonable environments, reasonable predictable environments. Other contributions can be included. Also, this is a big deal in open source and corporations because of this sort of wide distribution. I also touched on it, really tidy deploys are a big deal for CI. So a standard environment that looks like the production environment, or even a standard environment that we can configure the production environment to look like, any flavor of that. It gives a better view of what will happen when the code is merged in. You don't actually want to test on production most of the time. It's one thing to feature flag, it's another thing to do real live tests on production. We would rather get our testing environments as close to production as possible, as opposed to just say we have customers, hope that they don't see the problem. It also helps, again, prevent like forgotten customizations. Oh, I have this machine. Before the last Mac update, I installed this Ruby environment. This happened to me. I updated my operating system. Now it's all gone. Thank goodness I have another. I'm not testing on my own machine. Otherwise, that would have taken forever. We also see things like faster development with CI systems. So this was a really interesting study that we heard about, which is that CI both improves confidence in the code in an application and the pull requests submitted to it. So people, when there is CI, people feel better about the code they are maintaining, and they feel better about the pull requests they are receiving. So projects with CI will release about twice as often, and pull requests are accepted about almost 2, but 1.6 hours faster, which is a big deal both in open source. That means people can contribute better, as well as in business. That means you can move things along, and people's valuable time is, you can get more distance from it. There's a link there There are a lot of other interesting studies on CI out there as well. My email is at the end of the slide. I would love to send links later, but that's a good one. Also, CI will then function as kind of this automation hub. So I have this big long list here of coverage tool of different things that will happen. Code coverage being like how much of our code is tested. You may or may not want to test all of it. Some of it is illogical to test, but some of it really should be tested. Other things, linting, does this follow the best practices for syntax? Some languages will let you get away with syntax that you shouldn't, but it does make it harder to maintain and harder to read. Language runtimes. Does this run on Python 2.7? Does this run on Python 3.6? Does this run on Python 3.5? For libraries, this matters a lot. So I have a library of Python tests. Going to make sure this works. Everyone is using everything in Python 3, whatever. So I'm going to test that. I'm also going to backport it and just make sure this runs on 2.7 because maybe someone's on it. So you can do a lot of that with CI. Then dependency management, configuration management. These are all kind of, again, the libraries you're building on or the deployments you're doing. And various other things. I threw in some documentation generation. So there's some really cool frameworks for that. Demo generation, really cool frameworks for that. So this is where we start hooking up CI to CD, which we've talked about more. So CD being either continuous delivery, this is ready to be deployed whenever, or continuous deployment, this is deployed all the time, GitHub style. One way or the other, you need CI doing regular tests, because if we say every commit is deployable, conceivably we could deploy every commit, and if it's untested, we're back to the YOLO situation where we just hope. So that's the CI/CD interaction. Also, CI jobs will often spawn automated deployments, right? So, hey, this passes. I like it. It's on the branch that we allow to deploy. Let's just go and deploy it. That tends to be more in the continuous delivery category. So tests ends up being really, really important. If it's deployable every change, or if it's deployed every change, we want to have high confidence in the deployments we are doing. So a couple examples, and you will see some familiar faces. So these are just literally some build configurations I pulled out of open source so we can have a look at what exactly is happening. Hey. So CS50 manual, it was a fabulous little Travis YAML configuration to look at because, OK, you see the merge here. David was merging in pull request about last week, I think, and it was passing. And this was the Travis YAML. You can see the language, what version we're on, any sort of caching that's happening. The script is building that, making sure that the Jekyll build runs, and does this Jekyll project properly turn into the web page it's supposed to do? If it works, we're going to do a deployment. We're going to go to Elastic Beanstalk using this deployment process. We're going to use these secrets, which you can't see because it's open source and it's hidden. We're going to use these secrets to this part of AWS. App is named this, the whole thing. And then in the last bit, we're going to notify a Slack room. I assume there's a deployment Slack room or some interesting Slack room in which everyone is cheering on the manual. So we see CI both being hey, do this build, make sure it works, do this deployment, and also tell people it's done. This is one of our projects. This is one of the biggest glue projects at Travis. This is Travis Build, which takes this Travis YAML, this being a YAML configuration. YAML is a this sort of key value configuration language. So we're going to take Travis YAML, and we're going to turn it to Bash, Bash being a shell language, which the build is actually executed in. So this is a big, long Ruby repository in which a bunch of things are happening. This is sort of the key part of this build. So if we go back here, we have these 3 different tests. We're going to deploy it to key.io. And then there's an additional check these rake tests that happens after that sadly didn't fit on my slides. So again, here, we're going to run these tests. Beforehand, we're going to pre-compile and clean everything. We're going to run the test, the spec tests, do an additional validation test that we've written ourselves. And after deployment, we're going to send it to a code climate. Code climate being another tool for kind of checking the health of your code. There are all sorts of awesome tools out there, by the way. Just I'm shouting out this one because it's in our repository, but go find there's some awesome ones out there. And then, before the deploy, we're going to clean up. And then ultimately, we end up deploying it. So we have this project that goes from these individual steps, test, to clean up and get ready, deploy if it's the right kind, and take it from there. So I have a quick demo. Next, any questions before we get started? OK. And let me make sure this works. I thought I could only do one thing at a time, so I pre-recorded it, so I can pause if anyone has questions along the way. So here we see my Travis account, my travis.org open source account. I'm going to go and enable my demo Travis web project. So I did this cooking show style because the build is a little bit long. So here's the beginning of my pull request. And there's the pull request itself. I'm adding features. I'm adding an emoji to the string here. So you can see the first project. I actually updated the test first, again, so that I could know what the output was supposed to be. Right there. These two tests needed that updated because they're checking the string. Take it from there. I'm going to go back. Let's see if I'm remembering my demo. I'm going to go back and head back over to my editor there and actually update the code. So now that I've done the test, I'm then going to update the code and say this is what is supposed to happen when you generate a markdown string. You're supposed to also have that emoji. And I picked tools because we're building things. You can see what emojis I like. And now that we've done that, we're going to save it. And I'm going to come over to my terminal. That is my branch status. You can see what's happening. I'm going to add that file. I have a terrible habit of git add dot, which adds everything in the current directory. Don't do that habit. And then I'm going to commit it with a hopefully clear commit message. I'm going to push that up. This is just sort of basic, this is just sort of the general commit, git commit and git management tools. There are desktop apps. I like my command line. We're going to take it from there. And now the build is going to run. So build is running. See my pull request. That's my active branch. There's my build history. Apparently I like gesturing with my cursor. And it's coming in. Travis will show the build in this current page once it has started. So right now the build is going from, question, like a request coming into the Travis, beginning the pipeline, being parsed through things like Travis build until the worker is ready to start. And we take it from there. And here is the build coming in. So the first thing it's going to do is pull get Chrome stable, like Chrome for the browser, but in headless browser mode, so we can test like that. Taking a while. And then it's going to set up assets where we turn this source code. This is our entire front end, by the way. If you go to travis-ci/travisweb on GitHub, travis-web on GitHub, I forked that project and have done this on our open source front end. So now it is building the front end, downloading the build archive, which is the sort of some of these modules, some of these node modules that were set up in the prior build. There's a whole concept of if you have dependencies you can rely on, let's send them up to somewhere stable, in our case S3, and pull them back down for the next build so we don't have to pull it every time. Now we're getting the node version we need, which is kind of the underlying language here for this build, getting node 5. Installing the NPM modules, the node modules that we need again. And now we're linting. So we're checking, Does this exist the way it's supposed to? Is the syntax correct? All that good stuff. Does it match the best practices? And now we're building the website into something that we can automate it, that we can test automatically in the build. So it is going from source code to testable situation. And we're doing that. For better or for worse, I picked Travis Web because it is a nice, clear JavaScript project you can go and look at. It does have a fairly long build, so it will build for a little while. For some background history, we picked Ember because it works really well with our Ruby applications on the back end. And we have this nice Ember project. There are a lot of great JavaScript frameworks that have come out recently, more recently. Ember is neat if you like Ember. Highly recommend all these things. Again, these are all ways of building applications, building JavaScript applications, performant web apps in the browser. So now we're generating. Yes, question.
Are you a contributor to Travis project?
Let me pause real quick. Oops, too much of a pause. And we're back to the beginning. I'll figure it out. I contribute in different parts. So I'm on the product and support side. So odds and ends pull requests. I do a lot of reading our code because I end up explaining it to people. So I've pull requested to different configuration things. I've set up different infrastructure things with people, but I personally don't work on the Travis Web project. A lot of cool people do. But I'm happy to try and answer questions if you got questions about it. So, yeah.
If your project is not on GitHub, can you use Travis?
You cannot use GitHub. You cannot use Travis without GitHub, though. You could, if you have another source control project, you could add a second remote, and you would then be testing off the GitHub remote. It's a little iffy, but that is a way to do it. But right now, it is continuous integration for GitHub projects. We actually grew out of the GitHub open source community, so we've stayed super true to that. Other questions? Otherwise, I'll try and find my spot. OK. Let me see. And I think it was like halfway. Yep. Oh, wow, that's pretty good. OK. So we're linting. Going back to linting. The next things it will do is it will run all of the tests, or after it builds, it will run all of the tests there. I think I counted about 800 plus tests for all of these different things in this entire front end. So I'll skip a little forward. Whoop. Backward. Sorry about this. Let's skip to the end. So I've skipped the building step. The dots here are the tests that ran and passed. The stars are the ones we skipped. Sometimes you want to skip tests because whatever reason that component is still under work. It's not the best practice, but it is something that happens every so often. So now we are building all these tests, all 847 last I checked, and taking it from there. Yes?
It's not actually Travis, you're using some test runner to run these tests?
Travis is running the tests is running the NPM tests, the node tests here. There's a test runner that is executing these tests. We are automating calling that test runner. OK, so I'm going back to my pull request. I'm saying it worked, or I'm checking it. All my checks have passed. Now, because this is an individual pull request, I'm going to be wild and crazy and merge my own pull request. Highly recommend you get a review. But I added 3 emoji. It is OK. It will survive. So there's my pull request. And went pretty quickly. But in review, builds and testing in general. So the main goal is to provide a way for tests to be run as development progresses rather than at the end. CI came in as a theory in the 90s, but it's still a best practice that is being adopted. So we want tests to be run as the project is going so that we don't get to these great merge days where we go, OK, let's see if everyone's code fits together. Oh, my goodness, it doesn't fit together. Now what? Let's go back to the drawing board and figure it out. You have all that time that both requires, we need to figure out this problem, but also we did all this code and maybe it needs to be changed. Maybe it needs to go away. If you do these small increments, test them as you go, merge them in as you go, it's much more you don't waste time in quite the same way. It's much easier. You can also predict what other teams are going to do, because if you know everyone's tests are going to pass or they're not going to merge it in, right? Then you know that there's like side effects are generally under control. New features are tested with assuming the best practice of writing the tests with the features. And historical builds become a kind of living audit log for tests. So like, yes, my build last month did this. This is what the output is like. Oh, we've changed it a lot. Let me go back and compare. Or the last build that was successful did this, that, and the other thing. My tests, my project no longer is successful. What specifically has changed here? Let's go back and compare. When were these things done? Which commits had what status? There's tons of good data, tons of good information. And again, as you're doing your build, there are lots of different types of tests to include. So like the unit tests at the bottom, these are individual methods, component tests, integration tests, working your way up until you're testing the bulk of an application. Oftentimes people, again, will start with unit tests. If the unit tests don't pass, you know, particular methods are wrong, go and look at those. And then it connects back into CD and CI/CD, both in open source and in business and in industry. So CI and CD are getting more and more common. They are more or less considered a best practice, though of course every individual environment, every individual corporation, every individual project has like different requirements. So I don't want to be like CI is for everybody, but CI is for everybody. So it's both like a trend and a best practice. There are more and more, if you know your code is reliable at any given point and is tested and under control at any given point, you can do all sorts of interesting things around deployment, continuous deployment, other types of deployment, you know, changing around infrastructure, especially in kind of cloud native and all these cool stuff. So teams will use CI and CD for testing and deployment, also just general productivity. CS50 is posting to a Slack room. They're also all getting emails. They could be posting somewhere else. They could be notifying other things. We could be going back and saying, oh, we had an incident on our infrastructure. This is not happening with a manual, but say in another product we had an incident. What happened to the tests most recently? Can we fix this? Oh, we need to fix this really quick. Let's push this feature, make sure the test passed before we end up with an incident on top of our incident. So CI and CD are really deeply connected in that way, either by making sure you can deploy whenever or deploying always on passing CI, like CS50 does. So any questions? This was like very high level, but I would love to talk more about it. Questions, concerns, either about Travis or, yes?
Is there a particular reason that you rebuild the environment every time a new commit is pushed versus like keeping something hot and ready to go?
Yeah, so we do a bit of a mix of that with the caching, but the rebuilt environment every time does deal with changes to those environments. So either from our infrastructure side or from like your libraries and dependencies. Right, so we actually have a fairly continuous infrastructure project, infrastructure deployment, so we do that. It also works so that as we are changing our infrastructure, we'll change infrastructure and Travis build at the same time, Travis build being the runtime side. So if there's a change to infrastructure, we need to change to Travis build, and so we have pretty continuous deployment. We do have pre-built images, so we kind of have these catch-all images of like CI Garnet covers, like, I don't remember off the top of my head, but it covers, you know, half a dozen languages and their various types. CI Amethyst covers like all the stuff on the JVM and their various types. And so we will kind of have these catch-all images, and then when you select a language, we'll pull in all the specific stuff to it. It also lets for better like community involvement, so we'll have like the D language contributes to Travis build. I personally have never written D, but it's a supported language. Sure. Other questions? Yeah.
We've had like some issues. We also use like a different CI, but basically like,
Yeah.
if you make a change to say like a README file, is there like a way for like Travis to know like, oh, like that's not gonna break any tests, so we should really be running all the tests based on this change?
You can do like, You could, it depends on the workflow. So with Travis, I'm going to speak from Travis. From Travis specifically, you could just skip the entire thing by adding brackets skip space CI to the commit message. So you could skip the entire thing. You could set up a matrix build where you would set the environment variables. So this type of change would have these kind of tests. And then if we don't see any change or we want to pass it along, we could do that differently. We could do something different. You could also get rid of it out of the README on your pull request and then just, or get rid of it out of the Travis YAML on your pull request and then put it back. I would still say run the whole test suite though, because you don't know what changed. So different stuff. But also it will depend on project. So can talk more too afterward. Other questions? Other concerns about testing, CI? Other things? I can talk a little bit about how we use Travis at Travis, which is kind of fun. We've had different situations where in order to fix the builds, we have to pass a build, but the builds are stalled. That's really fun. Highly recommend that situation. We dog food all of Travis, both Travis open source, closed source, and enterprise. So you can't push a change to, say, Travis build unless your Travis build passes. So if you're changing it around, it gets super interesting. Questions, concerns? Otherwise, I can call it early. It was fast.
OK, well, thanks so much to Anna. And with that, we'll wrap up for today. And next week, we'll dive in to talk a little bit more about scalability and thinking about taking the web applications we've been building just on our own computers and how we might scale them to be larger applications used by some number of more users. Thank you so much.